Statistics Lesson 8.1, Basics of Hypothesis Testing. Develop the ability to identify the null and alternate hypothesis when given some claim about a population parameter. Develop the ability to calculate a test statistic, find critical values, calculate p-values, and state a final conclusion that addresses the original claim. Here are the components that should be included in the hypothesis test. Statement of the null and alternate hypothesis expressed in symbolic form. Value of the test statistic. Selection of the sampling distribution to be used for the hypothesis test. Identification of a p-value and/or critical value or values. Statement of a conclusion rejecting the null hypothesis or failing to reject the null hypothesis. Statement of a final conclusion that uses simple and non-technical terms to address the original claim. Some basic concepts of hypothesis testing. A hypothesis is a claim or statement about a property of a population. For instance, the average male height of an average teenage male height is 5'9". Hypothesis test. Test of significance is a procedure for testing a claim about a property of a population. Null hypothesis, H sub 0, is a statement that the value of a population parameter is equal to some claimed value. Alternate hypothesis, H sub 1 or H sub A, is a statement that the parameter has a value that somehow differs from the null hypothesis. For the methods of this chapter, the symbolic form of H sub 1 must use one of these symbols, less than, greater than, or not equal to. Let's try an example. In a Pitney Bowes survey, 1,009 consumers were asked if they were comfortable with having drones deliver their purchases, and 54% or 545 of them responded with no. Based on this survey result, is it reasonable to claim that the majority of consumers are not comfortable with drones delivering their purchases? But do the survey results really justify that claim? All right, so let's follow our procedure for hypothesis testing. 1, identify the claim to be tested and express it in symbolic form. So let's see here. Is it reasonable? It is reasonable to claim that the majority are not comfortable with drones delivering their purchases. So that's the claim. So identify the claim to be tested and express it in symbolic form. So we're going to say that P is greater than 0.5. All right, let's see. It is reasonable to claim that the majority of customers greater than 5 are not comfortable with. All right, good. Give the symbolic form that must be true when the original claim is false. So that's going to be P is less than or equal to 0.5. All right, it's really that simple. And let's see, 3. Identify the null and alternate hypothesis. So for number 3, well, the alternate hypothesis, H sub 1, is going to be P is greater than 0.5. Okay? And I know that was a lot of times what you're trying to prove is your null hypothesis, but in this case here, since we said it was greater than half, it'll be, and then our null hypothesis would be P is equal to 0.5. Okay. Now I know in number 2 we said less than or equal to, but for this course here, our null hypothesis will always be set equal to something. So now let's go on. Identify the test statistic relevant to the test and determine its sampling distribution. So basically, in this course, we're going to learn about 4 different ones or 5 different ones: populate or proportion, the mean, and that's if sigma is not known or the standard deviation is not known, and the mean if the standard deviation is known, two separate formulas. And then we're going to use the standard deviation or the variance. And for that, we're going to do this one here, and this is called chi-square. All right, now what we had was a proportion, because remember, n was 1009, and then x, how many that said no, was 545. So our p, or p hat actually, our p hat, let me drop that down a little bit. P hat is going to be 545 divided by 1009, which is 0.54. All right, and then here is going to be the formula that we're going to use. Find the value of the test statistic, then find either the p-value or the critical values. Okay, so we are going to find the value of the test statistic. So that formula was z equals, and we got p hat minus p over the square root of p times q divided by n. And we got p hat, that was 0.54 minus p is 0.5 over the square root of 0.5 times 0.5 over 1009. Okay, and we'll just put that in our trusty rusty calculator here. Control, divide, and 0.54 minus 0.5 over the square root, control divide, and then p was 0.5 times q, which is 1 minus 0.5, or 0.5, over n, which in this case was 1009. And we get 2.54118. So 2.54118. All right. So that's 6. That is 6. Test statistic is a value used in making a decision about the null hypothesis. It is found by converting the sample statistic to a score with the assumption that the null hypothesis is true, which is why we use 0.5. Critical region, the rejection region, is the area corresponding to all values of the test statistic that cause us to reject the null hypothesis. All right, now when it comes to test statistics, now if you remember over there, we said p was greater than 0.5. All right, so here is p. P is going to be right here, and that's going to be 0.5. Since it's greater than, what we're going to do is called a right tail test. Okay, and our critical region is going to be over here. And depending on what our alpha is, will depend on what the z-score, well, let's see, this will be our alpha here, all right? And then we'll find the z-score based on that. And then we'll see where this here falls. Whether if it falls inside of here, we will reject the null hypothesis. If it falls in the good zone over here, then we will accept the null, or fail to reject the null hypothesis. All right, so let's try. P-value is the probability of getting a value of the test statistic that is, hold on a second, did I skip something? Find the value of the testing. Okay, so no, we didn't skip nothing there. And no, we have not skipped anything. All right, so p-value is the probability of getting a value of the test statistic that is at least as extreme as the test statistic obtained from the sample data, assuming that the null hypothesis is true. All right, to find the p-value, we're going to do menu 675. You may want to put that in your notes. So let's go in here. And we're going to menu 675. All right. And our P is 0.5. That's our, and then successes, we found 545. N was 1009. And our null hypothesis was P is greater, or the null hypothesis is greater than. All right, so let's hit it. Our P-value is 0.005386. So our P-value is 0.005386. All right. Now we're going to find that was the p-value method. Now we're going to do the critical value method. All right. And this separates the critical region where we reject the null hypothesis from the values of the test statistic that do not lead to the rejection of the null hypothesis. Critical values depend on H, the null hypothesis, the sampling distribution, and alpha. All right. So how do we find the critical value? Well, we need to know what A is, or what alpha is. And in this case here, we'll use 0.05. All right. So our alpha is going to be over here, and it's going to be alpha is, that's a terrible alpha, 0.05. And that's going to be this area. Now we got to find out what that is. Now, if you remember, this whole thing is 1, right? This whole area here is 1, and this little area over here is 0.05. So we're going to go 1 minus 0.05, and that's going to give us 0.95. Okay, so let's go to our calculator, and we're going to go menu 553, and our area is 0.95, and there we go, and we'll press OK, and we got 1.645. So here we got 1.645. Okay. So that's our critical value, 1.645. Make a decision to either reject the null hypothesis or fail to reject the null hypothesis. Let's go back over here for a second, because we've already drawn it over here. What do we got? Well, if we do it by the P method, the p-value is 0.0, well, the alpha is 0.05. And then decision criteria for P, if the p-value is less than alpha, reject the null hypothesis. All right, and what did we have? That was 0.005. Well, that is less than 0.005386 is less than 0.05. All right. So based on that, we're going to reject the null hypothesis. Okay, we're going to say reject the null hypothesis. And that's the p-value method. Now, the other method, the critical value method, if the test statistic is in the critical region, reject the null hypothesis. So let's go back over here. Well, what did we find for the critical value? We found, well, RZ, remember RZ over here was somewhere out over here, and that was 2.54. Okay, and that's from back over here. Where did I do it at? Right there, 2.54. Well, 2.54 is over here, 2.54, and that is inside the critical region. That is inside the critical region over here. 2.54 is inside the critical region. So again, we will reject. The null hypothesis. Okay. Now, restate the decision using simple and non-technical terms. Without using technical terms not understood by most people, state a final conclusion that addresses the original claim with wording that can be understood by those without knowledge of statistical procedures. So how are we going to put this? How are we going to put this? And let me write this out for you. We're going to say there is sufficient evidence to support the claim that the majority of people or majority of consumers are uncomfortable with drone deliveries. Okay, so we rejected the null hypothesis, all right, and then we wrote this statement here. There, and this is for the layperson, there is sufficient evidence to support the claim that the majority of customers are uncomfortable with drone deliveries. Note, we use the phrase failed to reject the null hypothesis because the available evidence is not strong enough to warrant rejection of the null hypothesis. We cannot prove the null hypothesis. Okay, that's really, really important. Here's some that may help you writing some of your stuff. Condition: original claim does not include inequality, and you reject the null hypothesis. There is sufficient evidence to support the claim that, and then whatever the original claim was. Original claim does not include inequality, and you fail to reject the null hypothesis. There is not sufficient evidence to support the claim that, and then whatever the original claim was. The original claim includes inequality, and you reject the null hypothesis. There is sufficient evidence to warrant rejection of the claim that, and then whatever the claim was. Original claim includes inequality, and you fail to reject the null hypothesis. There is not sufficient evidence to warrant rejection of the claim that. Okay? All right. Not saying that you proved anything. Confidence intervals for hypothesis testing. A confidence interval estimate of a population parameter contains the likely values of that parameter. We should therefore reject a claim that the population parameter has a value that is not included in the confidence interval. The confidence interval is equivalent to a hypothesis test in the sense that they both reach the same conclusion for the mean, the standard deviation, and the variance. This is not always true for proportions. Okay, now it worked on this one that we just did, but it doesn't always work. So confidence level for confidence interval, and you might want to put this table down in your notes, okay, so that you can refer, or on a 3x5 card would probably be a good idea. All right. Type 1 and Type 2 errors. Type 1 error, the mistake of rejecting the null hypothesis when it is actually true. Alpha is the probability of a type 1 error, so which is the probability of rejecting the null hypothesis when the null hypothesis is true, which in that case, there was a 5% chance. Type 2 error, the mistake of failing to reject the null hypothesis when it is actually false. Probability of a type 2 error, failing to reject the null hypothesis when the null hypothesis is false. And here is a little routine for fun. Notice the constants are reject, true, null, and then fail to reject, false, null. Type 2, 2, and then type 1. And let's do a little let's do a little bit here. What do we got here? What do we got? And let's do a little. Let's see here. What if, let's see, preliminary conclusion. And we'll say we reject the null hypothesis and fail to reject. And then over here, we'll put true state of nature, true state of nature. And let's see, we got null hypothesis is true, and null hypothesis is false. All right, we're just making a little table here so I can show you how all this fits in. And then we got something that goes like this. And they're not exactly straight, are they? All right. Reject the null hypothesis when it is actually true is a type 1 error. And this right here would be a correct decision. And then fail to reject the null hypothesis when it is true would be a correct decision. And then fail to reject when it is false, this would be a type 2 error. And this is alpha here. And this is something called beta. Okay. Which just kind of leads into the values of alpha, beta, and n are all related. So if you choose any two of them, the third is automatically determined. Although beta can't be determined until an alternative value of a population parameter has been specified along with alpha and n. One common method is to select the alpha, then select the sample size that is practical, so the value of beta is determined. Generally try to use the largest alpha that you can tolerate, but for type 1 errors with more serious consequences, smaller values of alpha are generally used. And usually alpha, the most common is probably 0.5 and 0.05, and then 0.01, and then some use 0.1. Okay, but this right here is the two most common. This one being mostly in business and stuff like that. And this one here probably more in the medical field as a general rule. All right. Power of a hypothesis test, which is where I've been leading. The power of a hypothesis test is a probability 1 minus beta of rejecting a false null hypothesis. The value of the power is computed by using a particular significance level alpha and a particular value of the population parameter that is an alternative to the value assumed true in the null hypothesis. Just as 0.05 is a common choice for alpha, a power of at least 0.80 is a common requirement for determining that a hypothesis test is effective. Okay, now determining the value of beta is beyond the scope of this course. All right, we'll mostly be choosing alphas. And folks, that is all. Thank you very much and have a wonderful evening.